Hello my dear friends and welcome to today's class. It's our 9th lesson on the third topic of Form 3 work, which is called Newton's laws of motion. As usual, let me comment by giving you the quote of the day, which states that to be the best, you must be able to handle the worst. We shall discuss that quote at the end of our class today. So today we are looking at the applications of the law of conservation of linear momentum, and the first application is in recoil velocity of a rifle. So when a bullet is fired, its forward momentum is cancelled by that of the gun, which kicks back or recoils back. So that ensures that the forward momentum and the backward momentum is exactly equal, and therefore the total momentum, that is the total initial momentum and the total final momentum, is equal to each other, and therefore we say that the momentum of that particular system is conserved. The second application is in the garden sprinkler, or what we call the water sprinklers. So in the garden sprinklers, as the water jets forward, the arms and the nozzles recedes backwards and the rotation is maintained. So as the water jets forward, actually that provides the initial or the forward momentum, and the arms and the nozzle of that particular sprinkler, they recede or they move backwards, hence providing the final momentum and ensuring that the forward momentum and that is the forward or the initial momentum and the final or the backward momentum is equal. So that forward and initial momentum, when they are equal, then we say that the momentum is conserved, and therefore the rotation of that particular garden sprinkler or the water sprinkler is maintained. Then the third application is in the rocket and jet propulsion, whereby the forward thrust or the forward momentum is provided by the exhaust gases, which are expelled at a very high velocity at the rear end. So as the exhaust gases, as they are expelled out of those particular jets, they provide an initial momentum. As they hit the ground, an upward or the final momentum is provided, and therefore the jet is propelled upwards, or it moves upward. So that simply ensures that the total initial momentum and the total final momentum are equal, and therefore momentum is conserved, and hence the jet or the rocket continues moving upward. Therefore the forward thrust or the forward momentum is simply provided by the exhaust gases, which are expelled at a very high velocity at the rear end of the rocket and also at the jet. So this provides the upward motion or the forward thrust as the jet moves upward. Next, we look at frictional force, and friction is simply defined as a force that opposes the relative motion, or a force that opposes the intended motion. Therefore, that should give you a clue that frictional force will always act in the opposite direction, such that if a body is being pulled towards the forward direction, then the frictional force will always act in the reverse, or in the backward, or in the negative direction. So basically we have two types of frictional force. One, we have what we call static friction, and two, we have what we call kinetic friction. So static friction refers to the frictional force acting between the surfaces which are in contact but stationary. So when we have frictional force acting between two surfaces which are not moving or which are stationary, then such frictional force, we call it static friction. For example, assuming this particular block here was stationary, or assuming that it was at rest, or assuming that it was not moving, then the frictional force between the surface of this particular block and the surface of this, my rough surface here, which is in green. So frictional force between the surface of this particular block and the surface of this particular surface of mine, which is in green, the frictional force that will exist between these two surfaces which are in contact but which are stationary or which are not moving, we call that static friction. However, kinetic friction is now the frictional force acting between two surfaces which are in contact and which are in relative motion. So whenever we have two bodies or two surfaces which are in contact with each other and which are moving relative to each other, for example, one of the surfaces is moving relative to the other surface. For example, like in this case, if I have my rough surface here and I have my body being pulled in this particular direction, then the frictional force that exists between my surface which is moving, or the surface of this particular block which is moving, and this particular other surface, that frictional force is called kinetic friction. Remember, kinetic energy is just the energy between that is the energy possessed by a body in motion. So if we have our block moving in that particular direction, therefore the frictional force between the surface which is moving, that is the frictional force between these two surfaces which are in contact with each other but which are moving relative to each other, then we call that kinetic friction. It is also important to note that static friction will always be greater than kinetic friction, and also kinetic friction, sometimes it is called dynamic friction. So just try to imagine a case scenario whereby you are riding a bicycle. So the force that you require to start to take that particular bicycle from a state of rest to a state of motion, you require a lot of force, simply because some of the force that you are applying, you have to overcome the frictional force before that particular body starts moving. So the frictional force that you are overcoming when the body is at rest, we call that static friction. But if the body is already moving, then you apply more force so that it moves at a very high speed. Then the force applied, or the frictional force between the surface and the moving body, we call it kinetic friction. So it's just obvious that if you want to take a body from a state of rest to a state of motion, you require a very large force. So because you are overcoming what we are calling static friction. But if the body is already moving, then you are applying more force so that it moves at a higher velocity. Then in that case, the frictional force between your surface and the moving body is the kinetic friction. And you are saying that static friction will always be greater than kinetic, or what we are calling dynamic friction. Then we have something we call the coefficient of friction, and is defined as the ratio of frictional force to the normal reaction. So coefficient of friction is denoted by letter mu. Then this letter, we call it mu, it is a Greek letter. Then frictional force is denoted by F. Then R is the normal reaction. Remember, when we talk of a ratio, it means we are dividing two quantities, and a ratio usually has no units. So because we are saying that coefficient of friction is the ratio of frictional force to the normal reaction, in other terms, or mathematically, we are simply saying that coefficient of friction is given by frictional force divided by the normal reaction. That is what we mean by ratios. Therefore, coefficient of friction mu is equals to frictional force F divided by the normal reaction R. If I make frictional force F to be the subject of the formula, by multiplying both sides by R, I'll have frictional force F being equal to mu R. Therefore, friction is given by the product of the coefficient of friction and the normal reaction. So consider my body, which is in relative motion with my rough surface here. If this particular body is being pulled towards the right hand direction as indicated by this particular arrow, then the frictional force will always act in the backward, or in the negative, or in the reverse direction. Because remember, frictional force is a force that tries to oppose the intended motion, such that if the body is moving towards the right hand direction, the frictional force will always act towards the left hand direction in such a way that it tries to oppose the intended or the relative motion. Then the other force acting on this particular body, of course, we have the weight or the action, which is acting downwards, weight, mg, or the action force. Then upward, we shall have the reaction force, which is acting upward. Remember, an examiner can just draw for you the diagram, then they give you maybe that the body was being pulled towards the right hand direction. Then they ask you to indicate all forces acting on that particular body. So if the body is being pulled towards the right hand direction, we shall have the frictional force acting towards the left hand direction. We shall have the weight or the action force acting downward, and the reaction force will always be acting upward. Then frictional force also depends on the nature of the surface, such that rough surfaces will always offer greater frictional force than smooth surfaces. Yeah, actually smoothing the surface is one of the ways of reducing friction, as we'll see later. Then advantages of friction, or what we call the uses of friction. One, we have friction is very important in walking. Friction is also important in braking of cars. It is also important in writing, lightening a matchbox, box, etc. For example, for you, imagine a case scenario whereby there is a room, then they pour very that is soapy water in that particular room. So if someone asks you to walk from one point, from point A to point B of the same room, you are likely to slipper and fall down, because the soapy water tends to smoothen the surface, hence reducing the friction. Also, if you have maybe a car moving in a muddy area, when it has maybe rained, you realize that the ability of that particular vehicle to move well is interfered with, because the muddy area, it is a very smooth surface, and therefore the friction is very low. That's why the vehicle is likely to slipper. Also, in writing, we need the blackboards to be somehow rough, so that there is frictional force between your pen, or the mark pen, or the piece of chalk, and that particular blackboard. So when there is friction, your ability to write becomes easier. However, if that particular board was very smooth, if it was very smooth, or if you poured maybe some oil, or even some grease, or even some perfumes, you realize that your ability of writing with that particular pen will be very low, because you have reduced the friction. Even in your normal book, when you write in a book that is having some perfumes, you realize that when you try to write, the pen will somehow slipper away, because the frictional force is very low. Also, when you are lighting a matchbox, when the matchbox has some water, when that particular end that you strike with the matchbox, when it has some water, you realize that the matchbox will not light, because the water tends to reduce the frictional force between the rough surface of that particular matchbox, and that is the surface on which you are scratching that particular matchbox. So when there is water in between, the matchbox won't light, because the water tends to reduce the frictional force. However, if the surface is very rough, the ability of that particular matchbox lighting will be very high. Also, if you try striking the matchbox on any rough surface, for example on maybe a rough cemented surface, or on a wooden dry surface which is very rough, you realize that the matchbox will also light, because in such cases the frictional force is very high, because the surface is rough. Then the disadvantage of friction is that, one, it leads to loss of mechanical energy, especially in form of heat, and sometimes also in form of sound. Yeah, you realize that if you have maybe a wheelbarrow which has been used for a very long period of time, you realize that the wheelbarrow produces some sound. And also, if you touch the moving part, you realize that the moving parts are very hot, showing that energy is being lost in form of heat. Of course, if you want to reduce that, you can apply some material to smoothen the surface. For example, you can apply some grease, or you can also apply some oil to reduce the friction by smoothening the surface, or by applying some lubricants. Also, the other disadvantage of friction is that it can lead to wear and tear of the moving parts of the machine. Yeah, for example, a wheelbarrow, also a bicycle, or any other moving parts of the machine. Friction can lead to wear and tear of the moving parts. So of course, to reduce that, you can apply some lubricants. Then methods of reducing friction: one, we have lubrication, by applying lubricants, for example grease and oil. You can also use rollers. Remember, the lubricants, they tend to smoothen the surface, hence reducing the friction. The lubricants also, they separate the contact between the two surfaces, hence reducing friction. Also, you can also use rollers. So the rollers, they just reduce friction by separating the two surfaces. For example, assuming if this is one of our surface and this is the moving surface, you just apply some rollers in between my moving body and this particular surface. So what the rollers will do is that the rollers will separate the two surfaces which are having very high friction, because remember, friction can only take place when two surfaces are in contact. However, when you use rollers, the rollers tend to separate the two contacts, hence reducing the friction between them. You can also use ball bearing. The ball bearing also work on the same principle. They tend to separate the two moving surfaces. And remember, when the surfaces are separated, that means also friction is lowered down. You can also use what we call air cushioning, whereby you just bring the air in between the two moving surfaces. So when there is air in between, it means that the surfaces are not in contact, and therefore frictional force is reduced. Because remember, we did say that frictional force will only act if the surfaces, two maybe rough surfaces, are in contact. However, if you are using air to separate the two surfaces, it means the surfaces are separated, and therefore the frictional force is also reduced. Next, we look at viscosity. We are saying that viscosity refers to frictional force that is exerted by fluid. So frictional force in fluids, we call it viscosity. And viscosity is caused by intermolecular forces between the liquid or the fluid particles. Remember, when you talk of intermolecular forces, we mean cohesive and adhesive forces. Those are what we call the intermolecular forces. And remember, also when we talk of a fluid, we mean either a liquid or a gas. And we are saying that viscosity is the frictional force that is exerted by fluids. So that means if you have, for example, stronger cohesive forces between the liquid particles, it means also the frictional force or the viscous drag or the viscosity will be very higher. Therefore, viscous fluids, that is a fluid that exerts more friction, is said to be more viscous, or it is said to be viscous. Therefore, viscous fluids have stronger intermolecular forces, or they have stronger cohesive force of attraction between their molecules, hence they have high viscosity, or they have viscous drag between them. Examples of highly viscous fluids are liquids. We have the glycerin liquid. Also, we can have other liquids, for example, the porridge. For example, porridge is more viscous than water. That is, if you pour porridge and water on the same surface, then you allow them to flow, you realize that the water will flow over a longer distance, while the porridge or the glycerin will only flow over a short distance. So that one simply shows that porridge and also glycerin, they are highly viscous, or the frictional force between their particles are very high, or the viscous drag between the porridge and glycerin are very high as compared to the force of attraction between the molecules of water. Yeah, remember that cohesive force is very strong in glycerin. Cohesive force is also very strong in porridge. But in less viscous liquids, for example, in water, the cohesive force are very, very weak. That's why the water particles are free to flow from one point to another easily. So substances that flow easily on a surface, they are said to be less viscous, for example, water, and the intermolecular or the cohesive forces between the particles are weak. However, substances that when allowed to flow on a surface, they flow by a very small margin, they are said to be highly viscous. For example, we have porridge and glycerin, and for such substances, the cohesive force between their molecules are very, very high. Next, we look at when a steel ball is released in a viscous fluid, for example, glycerin or maybe porridge, or sometimes also oil has a higher viscosity as compared to water, then the forces acting on it are as shown below. Yeah, someone can ask you to indicate the forces acting on a body which is released in a highly viscous fluid. So the force acting, one, we shall have the upthrust force acting upward. Remember, upthrust force is an upward force that is exerted on a body immersed in a fluid. So upthrust force always acts upward. Then we also have the frictional force, or what we are calling the viscous drag or the viscosity, will also act upward, because the body, the steel ball, is being released into the fluid. If it is being released, it means it is moving downwards, because we know that the weight of a body always acts downward, because the weight depends on gravity, which tends to pull object downward. So because the steel ball is released downward, the viscous drag or the frictional force will act in the opposite direction, because remember, frictional force always tends to oppose the intended motion. Therefore, if the body is released downward, the frictional force will act in the opposite direction, which is the upward direction. Therefore, the two forces acting upward will be the upthrust force and the frictional force, while the force acting downward is the weight of that particular steel ball. However, the viscous drag and the upthrust force are due to the liquid, that is the glycerine. They are provided by the glycerine and will always act upwards, but the weight of the body, the weight will be due to this particular steel ball. So if you're asked to indicate the forces acting on a body immersed in a viscous fluid, if it is released downward, the weight will always act downward, while the upper forces will be the upthrust force U and the frictional force F, or the viscous drag or the viscosity. Then when the three forces balances, that is when the upward force and the downward force balances. Remember, the upward force, we have the upthrust force and the frictional force. Therefore, the total upward force is upthrust plus the frictional force. Then the downward force, we only have the weight acting downwards. So when the forces balance, when the upward force and the downward force balances, the body, in this case, which is the steel ball, it moves with a steady or a constant velocity, which we are calling the terminal velocity. So terminal velocity is just the steady or the constant velocity at which a body immersed in a viscous fluid moves with. That is the constant final velocity that a body which is immersed in a viscous fluid moves with. Then the graph of velocity against time for a body falling through different liquids is as shown in the table in the graph below. So viscous fluids, for example, glycerine, will always attain, will always have a smaller terminal velocity as compared to the substances which are less viscous, for example, water. So the velocity, that is the velocity at which this particular graph starts to flatten. For example, the terminal velocity for glycerin will be the velocity at this particular point. That is the velocity of the body when the graph starts to flatten. That is where we'll have the terminal velocity. For example, if the value of velocity at this point, if it was maybe 10 meters per second, then we will say that the terminal velocity of glycerin will be 10 meters per second. That is the velocity of the body when this particular graph starts to flatten. That is the terminal velocity. For water, for example, if the point where the graph started to flatten, if it was maybe at 20 meters per second, then we will say that the terminal velocity of water will be 20 meters per second. So the point where the graph starts to flatten, that is where we have the terminal velocity, And we have said that if a fluid is less viscous, the body will always flow through it at a very high velocity, and therefore the terminal velocity for less viscous fluids will always be greater than the terminal velocity for fluids which are highly viscous. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that to be the best, you must be able to handle the worst. So the quote is encouraging us to develop effective ways and methods of handling challenging moments in our lives. It is also encouraging us to work on our weaknesses until we become experts at everything we choose to do. That is, at things we feel passionate about. And lastly, recall that the greatness of a man is not defined by how much wealth he acquires. Rather, the greatness of a man is defined by his ability to affect those around him positively. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you will get a notification. Also, if you know any student or anyone that you honestly think could benefit from this content, kindly refer them to this channel. Thank you very much. This is Kind Tuition Academy. Until next time.